Good morning, good afternoon, folks. We'll start the webinar very soon. Thank you everyone for joining today's webinar from F5 and Red Hat, discussing solutions for running applications on the OpenShift platform. As we begin, I'd like to introduce myself and my colleagues who will run through this workshop with you today. My name is Owen Garrett. I work on the NGINX team within F5 on the product management team, and I'll be your lead speaker today. Supporting me is my colleague, Michael.
Yeah, hi, good afternoon, everyone. My name is Michael Cho. I'm a solutions engineer from NGINX, based out from Singapore. Nice meeting you all.
Thank you, Michael. And we have two special guests supporting us on the workshop today.
Good afternoon, everyone. My name is Laurent. I'm supporting the engineering team to help you, I would say, adopt the solution, transition to modern application, and secure them in the cloud and on-prem. So welcome.
Hi, everyone. I'm Michael Giesler from Red Hat. My team manages our alliances with partners like F5 and also the recruitment of new ISV partners in APAC.
Thank you, Michael. And then supporting us on chat, if you have any questions, please submit them. We have two panelists.
Hi everyone, I'm Ravi. I'm a solutions engineer from NGINX team based out of Singapore.
Hi, I'm Bukian. I'm a specialist solution architect for Red Hat, focusing on OpenShift. I'm also based out of Singapore. Nice to meet you.
Thank you, everyone. So as we begin, I'd like to keep this workshop as interactive and as useful as possible. So maybe we can start with a question for you, for the audience. This will help me as we go through the discussion. What are you hoping to learn from the workshop today? Are you new to OpenShift and Kubernetes and looking for some background information? Are you specifically looking at solutions from NGINX and F5? Have you got challenges giving control to your DevOps teams? And please, if more than one of these apply, do select multiple options. If you're just here out of curiosity, or maybe there's something specific you're looking for, use the chat to raise a question, and our panelists will help answer that as we go through the workshop. And as I look through the results from the poll, the vast majority of you, about half of the audience, have said they're new to OpenShift and Kubernetes. I'm looking to learn some of the basics and some of the best practices. A third saying specifically interested in NGINX and F5 solutions. That's a fantastic fit. I think this workshop will set you up very well with the background that you need to start planning out how to deliver production applications from OpenShift. NGINX F5 have been working very closely with Red Hat for many years with a rich technical partnership. And I'd like to hand across to Michael to talk through what that partnership means for you as an end user of NGINX and OpenShift technology.
Thanks, Owen. As you said, Red Hat and F5 have had a very strong partnership over many years. And in fact, last year we named F5 as our APAC ISV Partner of the Year. Probably the most important aspect of our partnership for our customers is that we deliver certified solutions that have been tested and documented. This provides assurance to our joint customers that these integrated solutions work as advertised. Can we just go to the next slide? Thanks, Owen. So this includes support for, one of the things that we'll discuss in our deep dive today, the integration of NGINX with our OpenShift container platform, automation of F5 products with Ansible, advanced security for our 3-scale API management solution, And in the telco space, network function virtualization support for big IP modules on our OpenStack platform. But I'll just say a few words about OpenShift. It seems like there's quite a lot of interest in the audience for OpenShift. So I'm hoping you get a lot out of this session today. Our OpenShift container platform is one of the most popular container platforms in the market today. And it's really at the core of our open hybrid cloud strategy. Recently, the Forrester Wave report on multi-cloud container platforms rated OpenShift as the clear leader in this space. One of the most significant leads that we've seen in these reports. We have thousands of customers around the world who have made significant investments in OpenShift as their container platform of choice, and including many of the large banks and telcos in APAC. We have a rapidly growing ecosystem of ISV partners like F5 investing in support for OpenShift, with hundreds of certified solutions in the market today. In fact, in APAC, we've seen a rapid increase in new ISVs building their solutions and certifying their solutions on OpenShift. So with that, I hope you enjoy the session today, find it very informative, and I'll pass back to Owen.
Michael, thank you very much for the introduction. So indeed, there are a large number of successful deployments of the OpenShift platform with F5 and NGINX technology on top, helping deliver applications in a reliable and secure fashion. And one of our key stars within this region is my colleague Laurent. Laurent, would you mind talking through one of the successful deployments that you have worked with customers to achieve?
Thank you, Owen. Yes, we have a very good and fruitful collaboration with one of our customers. They are a company who is providing and developing solutions and financial solution software for insurance companies that goes around accounting, managing customers, and managing assets for the customers. And they had a challenge with transitioning from monolithic applications towards microservices application and modern applications. So they were really, I would say, facing a few challenges. And the first one was how to orchestrate and to operate those new version of their services, which was built around 15 microservices per customer to make sure that each customer has the set of functionalities and features that they wanted to operate and to use, and to start getting into, I would say, a more modern deployment and benefit from those evolution that this insurance company was providing. They also had a strong need to deploy the infrastructure on top of Azure. And that was really motivated by the fact that they had just recently a new data center of Microsoft deployed close to them. So of course, that was a good benefit for them to provide good performances to their end users. And as they were moving toward that new modern architecture, they were also planning for a bigger growth. And that was also a challenge for them to make sure that their architecture would stand and would sustain a huge number of, a growing number of customers. So we worked with them and we entered a, I would say, discussion and labs and workshops to evaluate how they would deploy a Kubernetes architecture and infrastructure, how they would learn how to operate that infrastructure. And along the way, we all, I would say, learn from each other. We guided them on the Kubernetes, I would say, the skill set, and they also learn through our discussions. They also discuss with us on their challenges from a security perspective, because of course they were hosting those applications for their customers. So they had security challenges and resources challenges to address and to make sure that they could deliver those capabilities. So capabilities like rate limiting were key to them, and job authorization was also something that we, I would say, take them through. And after successful, I would say, POCs and implementation, they validated that the whole design was really capable of scaling up and scaling down to match their customers' demand. And with the NGINX solution deployed on Azure Kubernetes services, they had something that was completely matching their needs. So I hope this example illustrates what the audience is expecting, how to manage traffic around OpenShift and Kubernetes in multiple and modern application environment. Over to you, Owen.
Great, thank you, Laurent. So absolutely, we'll delve into some of the techniques that this customer used to build a scalable, resilient, and high-performance architecture on top of OpenShift. So let's begin with understanding some of the solutions that we can bring to bear to help leverage OpenShift and applications running on those. And often we're asked, why, first of all, did NGINX and F5 partner up? The reason for it is quite subtle. As many of you will know, F5 has a very, very rich and powerful set of appliance-based solutions for delivering applications and providing load balancing, security, DDoS capabilities for those apps. And users like yourselves will rely on a wide range of services and solutions to deliver applications, whatever platform you're using. But the fact of the matter is that within your organization, there are probably distinct teams with distinct roles or imperatives for how those applications are delivered. The DevOps team focuses very much on a per application basis, wanting to ensure that that application is delivered and they can use the services to control how the app is delivered, to perform upgrades and updates and monitor the performance of that individual application. Whereas the NetOps or operations teams often take a much more global perspective. They want to ensure that the infrastructure that is used by all of the applications is secure, resilient, performant, and meets the needs of the business. And where these two teams or tribes meet in the middle, there's often a need for both of them to have access to API gateway, load balancer, or security functionality. It gets further complicated when you bring in a platform such as Red Hat OpenShift, because OpenShift is also capable of hosting ingress controllers and load balancers and web application firewalls and the like. And NGINX comes into the story because as a software-based solution, small, lightweight, it's very easy to deploy and scale on OpenShift, giving you the footprint to deploy the load balancing and application delivery capabilities that you need directly within OpenShift. Often, OpenShift is deployed along with a set of edge services that could be based on NGINX or F5's Big IP, or indeed any other edge load balancing and proxying solution for load balancing and security and API delivery. But we see a very large footprint of NGINX within container platforms because NGINX is ideally suited. As I mentioned, extremely lightweight and small. It is just another Linux application, so extremely easy to embed inside a container. And indeed, in Datadog's report from last year, they saw that NGINX was deployed within more than 50% of the organizations they were monitoring, more than any other open source solution. And a very specific use case within OpenShift and Kubernetes is the Ingress provider use case, the load balancer that sits at the edge of the Kubernetes or OpenShift platform, bridging the external network with the internal networks inside that platform. And again, NGINX is the top solution chosen by CNCF members to be an ingress provider or service proxy. So with NGINX being such a strong fit and such a common deployment technology within OpenShift and Kubernetes, how do people use it to improve the way that they deliver applications? Well, let's start with the problem statement. Our problem statement is that we have a number of services running inside Red Hat OpenShift. and we wish to expose those services to external users outside of the OpenShift platform. But we have a couple of additional challenges. We want to be able to do this in a way that is secure and reliable and works for our DevOps team. As we mentioned before, the DevOps team have very specific expectations of the solutions that they use. They're application-centric, they're fast, they're responsive, and they can be used immediately without having to collaborate with a NetOps or operations team. We also want a solution which is multi-tenant, because as our OpenShift platform grows, we will find there are more and more teams who are using that platform to host their applications. And by multi-tenant, what I mean is that we want a way of separating each of those teams so that they can operate independently without using each other's resources, without stamping on each other's footprint. There are a range of established solutions for getting traffic in and out of an OpenShift or Kubernetes platform, but the solution that fits these requirements best of all is the Ingress controller, or in the OpenShift case, the OpenShift router. It's a discrete load balancing layer that runs in the cluster, accepting all traffic coming into that cluster and then distributing it intelligently across the different services within. So as we keep it interactive, I'd like to raise another question to the audience. When you publish applications on OpenShift or indeed Kubernetes, what technology do you use to get traffic into the services running on those OpenShift or Kubernetes platforms? We'll give it a moment for the answer to come in. And I appreciate that many of you said that you were new to OpenShift or Kubernetes. So if you don't have a production deployment, don't worry. Let's wait and see what those who are forging ahead are using. And as the results come in, as I look, we're finding it fairly evenly spread. About a third of our users that have responded are using the OpenShift router as the edge load balancer. Exactly the same number, so about a third are using the Kubernetes Ingress controller as a way of doing that. A small number are using a third-party Ingress controller, and almost a third of you just don't know. You're not sure what solution is being used, which is fine. There are some good default solutions, but as we'll see as we proceed, if you're careful about what you select, you can unlock a lot of capabilities that will benefit your DevOps teams. So thank you for the results. There are two primary solutions that you could use on Red Hat OpenShift. The default solution, bundled as part of all OpenShift deployments, is Red Hat's OpenShift router. And this router is required on OpenShift because it's required for some of the built-in services that run on top of OpenShift. But you can also use it as the Ingress controller for your own services within OpenShift. Fully supported, it's configured using a concept called an OpenShift route, which is a simple resource that declares that a service needs to have external access. It offers a good core set of features. It is able to deliver multiple different services across multiple different tenants. And because of its capabilities, its performance, the feature set, it's ideally suitable for internal Kubernetes OpenShift services, for pre-production, and for some simple production use cases. Red Hat were a leader in this space. They pioneered the concept of an OpenShift router long before the Kubernetes community team approached this problem. When the Kubernetes team approached this problem, they took a different approach, a concept called an Ingress controller. And there are a number of different Ingress controller implementations, the leading one of which is NGINX's Ingress controller. This, I point out, is different to the default NGINX Ingress controller that's shipped with Kubernetes. That community solution is a little bit more basic and lower performant than the specialized ingress controller that's built by us. The authors of the NGINX project, we've also built an ingress controller with NGINX at its core. This solution is fully supported in both OpenShift and Kubernetes. It's configured using Kubernetes ingress resources rather than OpenShift routes. So a Kubernetes standard. We've also extended it with our own NGINX Ingress resources, which unlock a much more advanced set of functionality. We'll see use cases shortly around rate limiting or sophisticated routing of traffic using NGINX Ingress resources. It has a much broader multi-tenant capability. Individual tenants can define services. Admin tenants can define listeners and the security policies around those. And other tenants, maybe the SecOps tenants, can define particular policies such as access control lists or web application firewall configuration. And this wider set of functionality, along with the multi-tenant capabilities, mean that it's suitable for much more advanced large-scale production use cases. We could delve into some of these functionality differences. Very quickly, although on the surface both provide basic proxy-based load balancing functionality, the NGINX solution has a much more sophisticated and richer configuration method, a full DSL domain-specific language to make it easy for you to configure advanced technologies in an intuitive fashion. The NGINX solution adds support for additional protocols, support for additional ways to handle and respond to HTTP traffic, sending back redirects or direct responses, much richer ways to route traffic, capabilities around health checks and slow start to bring new services online gently, advanced authentication and web application firewall capabilities, much richer multi-tenant support and richer observability. The NGINX Ingress controller can be built using either NGINX open source or with our commercial NGINX Plus version of the NGINX product. With NGINX Plus, you get full support from both NGINX and Red Hat, and it unlocks some of the additional capabilities around health checks, authentication, and web application firewalling. And so what we see is that when organizations deploy a platform such as Red Hat OpenShift, that when they begin with simple application requirements and a small number of teams, the default OpenShift router is a good solution. But as they begin to scale with many teams, 2 or 3 or more teams sharing the same platform, or they have richer, more sophisticated requirements for their applications, then the additional capabilities of NGINX Ingress controller, or indeed the NGINX Plus based Ingress controller, and the operator are ideal to help support organizations scale. So I've talked a little bit about how you can find scalability problems with large numbers of teams, or you can find functionality problems as you get more and more complicated applications and the DevOps team looks for more from the platform. So this is a question for maybe the experienced users who are using Red Hat OpenShift or Kubernetes. What limitations do you find when you deploy in production? Do you find that it's challenging to operate the platform when there are large numbers of applications with different requirements? Do you find it challenging to operate the platform in a secure and scalable way when you have large numbers of teams, multi-tenant? Do you come across performance problems with the default solution, such as the Red Hat OpenShift router? Do you find that the features that some of the default solutions that you deploy are limited and you need to shore those up with additional capabilities, such as web app firewalls or proxies? Do you find it's just too complex to use all those features? So the results are coming in, and we're finding that indeed operating at scale with large numbers of teams, multi-tenancy, is the top challenge that people report. And the second challenge is the complexity of configuring the Ingress solution. let's dive into some of the ways that you can address and solve those challenges. So both multi-tenancy and complexity of configuration. Those are things that NGINX Ingress controller is ideally suited to address. And we'll begin with a quick high-level introduction as to what the NGINX Ingress controller is. For those of you who are familiar with the OpenShift router, this will be a familiar pattern. An Ingress controller, like an OpenShift router, sits at the edge of the Kubernetes or OpenShift platform, and it bridges the external network to the internal network. So it's often deployed as a node port. It takes its configuration from a set of resources inside the Kubernetes API. So Ingress resources that are published by the operator, the DevOps team, to specify what services should be exposed, and service information to understand the health and the availability of individual services. And with that information, understanding what it's been asked to do and what's happening within the Kubernetes or OpenShift platform, it then configures the internal load balancer appropriately. In the case of NGINX, the Ingress controller is a single pod that contains, starting from the bottom, either NGINX open source or NGINX Plus as the core load balancing proxy. And additionally in that pod is a configuration service, the Ingress controller daemon, that listens for events and resources within Kubernetes and builds the NGINX configuration. If something were to change, so a service was to be added or a pod deployed, then the Ingress controller daemon will reconfigure the underlying NGINX or NGINX Plus instance. In the case of the OpenShift router, the service uses a set of templates to take the current state and to transform it through a template into an HA proxy configuration. That's a relatively fixed and inflexible configuration method. With the NGINX solution, we have a full domain-specific language, so we can generate very sophisticated and detailed configurations. One of the benefits of using NGINX Plus as the load balancer is that NGINX Plus has an internal API that can be used to reconfigure it more quickly without the impact of reloading configuration, giving you a consistent high-performance environment. And as I mentioned, an Ingress controller is configured using an Ingress resource. A simple example on the right-hand side. This basic example will look familiar to anyone who's used either Ingress controllers or OpenShift routers. On OpenShift, the Ingress controller is deployed most easily using an operator. An operator makes it trivially easy to deploy and manage and scale your Ingress controller cluster. And what I'll do now is I'll hand across to my colleague Michael, and Michael is going to show you how simple it is to get the Ingress controller up and running on the OpenShift platform.
Yeah, thanks, Owen. Yeah. Hi, for people who just joined, my name is Michael. I'm a solution engineer from NGINX. So today I'll be responsible to show you through how easily to configure NGINX as an Ingress controller and how to take advantage of some of the advanced capability as well. Right now, if you can see, this is my home screen. So I just want to show you some of the resources where you can get help from. If you go to nginx.com, our main website, the resources under documentations, right? Let's show you. So NGINX Ingress controller for Kubernetes. The same thing is applicable for OpenShift as well. In the overview, scroll down here for installations. So to install NGINX as an Ingress controller in the Kubernetes or OpenShift, there are three methods. You can install through manifest, installation through Helm file, or install through Ingress operator. Right. For these demonstrations, I'm going to use the operator mode as well. Right. So here, I have one. In my demo environment, I have one OpenShift cluster running. So just want to show you OpenShift OC get nodes. I have 3 master nodes running and 3 worker nodes running, right? And then right now, if I go and get a CRD, custom resource definitions, and to grab NGINX, is empty, right? So this it hasn't been installed anything with an Ingress controller. And get ports in the namespace for NGINX Ingress. I created a namespace specifically for Ingress controller, and there's nothing inside the namespace as well, right? So how am I going to install this Ingress controller? It's very simple. In the OpenShift dashboard, operator hub, right? So this kind of different vendor publish the operator. In the search box, you just need to type NGINX, and then there's an NGINX Ingress operator. Now, this operator will be responsible to take care of the life cycle of the Ingress controller. I just need to click on install. And then because I already created a namespace previously, NGINX Ingress, the rest I will leave it as default, and I click install, right? So right now, let's take a look, right? If I go back to check my ports in any running port in the Ingress NGINX namespace, yeah, this operator has been installed and running. Now, let's check back the custom resource definitions. As you can notice, it's all dependency of the underlying custom resource definitions, or all the required resource definitions you created as part of the installation of this operator, right? So the next step I need to do is I need to deploy the Ingress controller. So basically I just click on Ingress controller, create Ingress controller, right? Now here, there's a kind of form for you, which you can go through. You can create name, the labels. You want to deploy as a node port, or you want to deploy as a deployment or daemon set. Early on, I saw there's a question about how to ensure high availability for the Ingress controller. You can deploy as a deployment or daemon set as well. And then there's what's an Ingress class in case you have multiple Ingress controller. Yeah, you are right. You're able to run multiple copy or multiple different versions of Ingress controller within a cluster, right? There's some of the informations you want to monitor specific namespace, or this Ingress controller applicable for this namespace for this project team, and then Ingress controller for another project team as well. And then there's App Protect. This is a NGINX Plus versions or optional versions that you can use web application firewall in the Ingress controller. So there's a lot of information, a lot of customization that you can do on that as well. Now, for ease of configurations, you can click on the YAML file here as well. Now, I already pre-populated some of my configurations. Just predefined yeah. So I'm running my the image files, the node port, yeah, etc. Pay attention here. So I also expose this is only applicable for NGINX Plus. There's a dashboard, so I kind of listen on port 1990 in case I want to monitor some of the statistics. So just click deploy, right? Let's get back to my OC command, ports. So right now I have a controller which is early on deployed, and I have an operator which early on deployed, and right now I have an Ingress controller which is running right now, right? Now, because just now, as I say, NGINX Plus have a dashboard that you can monitor the configurations file, right? So for me, there's something called I can do. If you are familiar with Kubernetes or OpenShift, you can do the port forwarding to my listening port. So right now I do the port forwarding, and then I just go back to my dashboard. So NGINX dashboard. Yeah, so this is basically showing the NGINX controller has been up and running. There's no configuration because I have yet to deploy the custom resource or Ingress resources. I think this basically concludes my first part of sharing. Back to you, Owen.
Thank you, Michael. So as we've seen, it's very quick and easy once the operator is installed on your platform to then deploy the NGINX Ingress controller. And this is the first step to delivering applications successfully from the Kubernetes platform and the OpenShift platform. So let's now look at some of the things that you can do once the Ingress controller is deployed. There are two challenges, as I mentioned, that you face at scale. How can multiple teams and how can multiple applications share your OpenShift environment successfully? Do it in a way that is safe and secure, where you allocate resources and you provide isolation between the different teams. And when the applications become more sophisticated, or the expectations and requirements from your DevOps team grow, how can you provide the advanced capabilities that those applications and teams require. We're going to look into these two particular requirements as we go through the abilities and capabilities of the NGINX Ingress controller. Let's begin by considering the multi-tenancy requirement. What are the good or best practices that people use for allowing teams to share a Kubernetes or OpenShift platform? And we'll begin with a question for you, the audience. For those of you who are using OpenShift or Kubernetes, what strategies do you use to separate applications from each other so that there's no resource contention, so that teams can operate independently and securely? And we'll give it just a few seconds for people to respond and to respond to this question. Results are coming in. Yep, they're beginning to settle now. Okay, so I'll share the results. So what we see very strongly is that people use hard role-based access control solutions. And by hard, what I mean is not that they're difficult, I mean is that they're firm and they are secure. So namespaces are key for there. That's a great response. The CNCF asked a very similar question of their members each year in their survey, and we see very, very similar results. So just as you responded with namespaces first, then separate clusters, then labels, and finally no separation, we have a very similar pattern. As organizations scale with multiple teams, then they tend to use labels less and concentrate very much on either separate clusters or still popular namespaces as a way of isolating and separating tenants running on Kubernetes. Namespaces are a key technology that any solution needs to be able to support effectively, so that as administrators, you can use namespaces as a core for your role-based access control on shared clusters. Let's take a second question for the audience. As you think about your OpenShift router or your Ingress controller, and again, this is a question for the practitioners, experienced users of OpenShift or Kubernetes, what do you do to configure advanced capabilities? And typically these methods of doing advanced capabilities override the internal templates or the default way that the Ingress controller processes input in order to add more configuration into the config that is sent to the underlying load balancer. So maybe you don't do anything sophisticated. You just go with the default capabilities you're given. Maybe you rely on using annotations or config maps in either Kubernetes or OpenShift to extend the configuration. Or in some cases, you might want to edit the configuration template directly. A technically challenging task, but one that's necessary if you need to access the advanced capabilities of the underlying load balancer. And yes, what we see is that almost half of you will use annotations or config maps in order to make custom extensions to the Ingress controller configuration. And these are challenges. The Ingress controller or the OpenShift router is configured using either an OpenShift route or an Ingress resource, which is a fairly basic object within the Kubernetes or OpenShift API. It exposes a common set of parameters, what you would like to listen on, the name of the service you would like to route to, and maybe a path mapping to say a particular request for a particular path, go to one service, requests for a different path, go to a different service. And this core lowest common denominator functionality is offered through the Ingress resource or the OpenShift route. But as we've seen, behind all of this, within the Ingress controller or OpenShift router, is often a very sophisticated load balancing or proxy solution. HA proxy in the case of the OpenShift router, NGINX in the case of the Ingress controller. NGINX offers over 600 additional directives based around functionality such as authentication or proxying that you can fine-tune to control how traffic is routed and load balanced. And those directives are not exposed through an OpenShift route or an Ingress resource. You have to use technology such as annotations or config maps to access some of those directives, or potentially even edit the underlying templates and rules that the Ingress controller uses. All of these additional capabilities are specific to each vendor, so they're not portable. There's often very little type safety. Annotations and config maps can't easily be verified and checked within the Kubernetes or OpenShift API. They are of global scope, not fine-grained. By that, I mean that when you supply additional configuration through a config map, for example, that's applied to all traffic. It can't be pinned down and applied to a particular path or a particular service. And they're generally difficult to work with because the relationship between the annotations and the config maps and the core configuration is not clear. You need to be fairly expert in order to unpick and understand how all of these things tie together. So what we've seen resonates very much with what people have said. In order to extend a configuration, you need to use annotations and config maps, but these are difficult and unreliable to use. On the previous poll, people supported that one of the biggest challenges of using Ingress controllers was the complexity of configuring them. At NGINX, we set out to address this problem head-on and build a solution that was sophisticated so it could address a number of different use cases, but was as easy as possible and as intuitive as possible to use. We started with a solution which we call NGINX Ingress resources. It is a different schema based on the standard Kubernetes Ingress resources, but extended heavily, that allows you to configure NGINX in a much more intuitive fashion without having to resort to annotations, or config maps, or direct template modifications. And schema begins with an object called a virtual server. You will have seen in Michael's demo, when he deployed the Ingress operator, one of the things that it did was deploy a set of additional CRDs, custom resource definitions. And it's those CRDs that represent the objects I'm going to share with you now. We have a virtual server object, which is a richer version of an Ingress resource that allows you to define where you listen for traffic and then the routes that you handle traffic with. And that virtual server object is fully defined with a spec in the API, but to support multi-tenant use cases, you can split it up optionally into a virtual server that handles the listening for traffic and a virtual server route that delegates the load balancing of that traffic to a different team. And we'll see in an example shortly how you can use that to support multiple tenants in the same environment. There's a rich range of functionality to handle traffic, to match requests, to implement things like A/B tests and canary releases. And to address additional capabilities in NGINX, we have the concept of policies. Policies implement specific NGINX-based functionality, such as access control or mutual TLS or rate limiting. And they can be attached or referred to at various points within your configuration, globally, at the top level, or against a particular path, with a policy at a route level. And then, for the few use cases where you need to implement something really sophisticated, something which goes beyond what we support through the CRDs directly, you have a safe way to embed NGINX configuration directly into your virtual server at either a global level in the server and HTTP context or at a path level in the location context. This is a really solid solution for someone who is an expert in NGINX configuration and wants very fine-grained control of the underlying config. So let's begin and look at what a basic Ingress route, basic virtual server configuration might look like. On the left-hand side, we can configure how individual requests are processed. So for a request that matches a path of /coffee, we can pass it to a service named coffee. Or in a type-safe fashion, we can implement a configuration that says, if someone asks for /coffee, that resource is moved, so we'll send back a redirect. We can even directly send a response, a simple response from the ingress controller for a particular path. Then if we build this up on the right-hand side, you can see a rich implementation of this solution, where we are implementing a proxy that is load balancing to an upstream called coffee, but we can also make changes to the headers as the request goes through and to the response. We can hide particular ones, and we can optionally rewrite the path as well. So bringing all of these things together, you have a rich set of capabilities that matches what NGINX is able to do to control how traffic is proxied and load balanced to upstream servers. Let's take a quick demo, and I'll hand back to Michael. Michael, would you show us how simple it is to set up a basic load balancing configuration, switching traffic with NGINX Ingress controller?
Yeah, sure. Thanks, Ruben again. Yeah. So right now in my screen, I can show you is the official GitHub repo for NGINX company. So if you can look at here, Kubernetes Ingress. Here is that's where you can find a lot of information on how you can deploy the Ingress controller, build an image, as well as some of the examples. Sorry. So here there's details of information that you can find from here as well. So for this, but specifically for this workshop, I have prepared a stripped down or separate a repo for containing all the demos. So right now, I'm going to show how easy to deploy a virtual server custom resource. So first of all, I have this cafe.yaml file. This is my application deployment. So there's a coffee deployments and coffee service, as well as tea deployment, tea service. Just imagine right now there's this project, and this cafe project consists of two different project teams, two different group of developers, coffee developers and tea developers. So each of them build their separate applications right now, right? So yeah, so this is the deployments, the applications, and because I want to run on HTTPS, hence I have a secret file to contain the certificate and private key. And how do I tie everything together? How do I make these applications accessible from outside the cluster? That's where the custom resource virtual server come out, right? So earlier on, throughout in the earlier survey, some of the people you say that you're using a notation on or config map to modify the ingress controller. Sometimes because of annotation, like what Owen said, it could be very it's not type safe. It's a lot of complications. There's no granular control. But for this, it's the custom resource by NGINX virtual server. So right now I'm running on host cafe.example.com. This is my SSL HTTPS, and then I have upstream server. There's a tea service as well as a coffee service. For me, in this demonstration, what I want to show is if let's say the request /tea, I want to route it to the tea service. If the request comes to /coffee, I want to route it to the coffee service. So this is very, very straightforward demonstrations. Now, in this demonstration, I can potentially expand it further as well. The tea could be running on a separate tea namespace. Coffee could run on the coffee namespace. But for simplicity for this demonstration, I just put everything into the single the namespace, right? So right now, after this workshop, we will share some of these useful links as well. Everything in particular for this workshop, I prepared all the YAML file, all the resources required, kind of self-contained in the individual folder. All I need to do is, but basically I do the clone to my local drive. So I just OC apply -F all the files into this folder, right? 02. Yeah. So basically, what you've just done is create a secret, create a virtual server resources, and then they do all the deployment. Now, so let's come back to my the NGINX dashboard. Usually you don't have to monitor here, but I just want to demonstrate to you underlying things. So in NGINX Ingress controller, because I already deployed the applications, it's kind of auto discover as an upstream server, right? So right now, back to here, if I click on coffee service, you can see this is running. If I refresh, it kind of load blends to different port number at the back. If I click on the key, then you refresh, there's a lot of, you just do the load balancing as well. Now, this is just very simple demonstration, but you can definitely expand further as well. I want to show you here back to the our official website. If you click on this configurations, and then virtual server route, there's a lot of flexibility and control that you can have to build up your use case as well. I think that's conclude this round of demo, and pass it back to you, Owen.
Thank you. Thank you, Michael. So we've seen how straightforward it is to route different requests to different upstream services inside Kubernetes or OpenShift. And we discussed some of the things you can do for directly responding or sending redirects instead. But that's just the beginning of the kind of use cases that you might want to meet on a sophisticated platform. You might want to do split routing between different versions of a service. Kubernetes and OpenShift can support a basic deployments scenario to do a blue-green deployment where you wish to deploy a new version of a service and load balance traffic to it. With the Ingress controller, you can do much richer and far more fine-grained control, running two different versions of a service and dynamically controlling the weight using split routing of traffic between those two different services. Great example for a canary release, where you want to release your V2 of a service and give it just a tiny proportion of the traffic before you can be confident it's operating correctly. Or you can do smart things with conditional routing. You're not just limited to switching traffic based on the path or the URL in the request. You can use advanced tests, matches. You can look at the method. You can look at the user. You can look at the value of cookie. Any request parameter can be used in order to switch traffic to different pools. You might want to use this if you were, for example, to deploy a new version of a service on your production platform, but you only want internal users to be routed to that new version of the service. And that way you could safely test that new version in production. Users coming from a particular IP range or with a particular cookie go to the new version of the service, whereas regular users, production users of the application, continue to be routed to the current production version. So many different solutions can be built using this technology. With the NGINX Ingress controller, you can also implement custom error pages. So if a service has failed, perhaps because there are no pods in that service, rather than returning a bland and unhelpful error message from the Ingress controller, you can override that message or provide a redirect to a different service. You can use this to implement a circuit breaker pattern. NGINX Ingress controller can health check a service, and if the service has failed, it can immediately respond with a canned response. For example, you might have a service that implements a search function, and users would expect that would respond back with a list of search results. You could create a circuit breaker response that returns back with an empty list, so that when users access that service, they don't get an unhelpful error message, they at least get a response that the application is able to process. Michael, would you mind sharing with us how you can do some of these things running on OpenShift?
So right now, I'm in this round of demo, I'm going to show you two use cases. So use case number 3 and use case number 4, right? So in the use case number 3, like what Owen said, right, sometimes the application, because of certain error, it couldn't, it's not available and it's not returning. If let's say you just bluntly return a 404 or 502, it's not helpful to the customer, and then it's not good for branding as well. So in this demonstration, I want to show you how easy to create a custom error message, right? So again, earlier on, I have a cafe deployments, and then so the only thing difference here is in it again back to the virtual server, right? So for here, I can say under this coffee path.
Yeah, Michael, don't forget to share your screen.
Oh, I'm so sorry. I clicked share, but I didn't confirm it. I'm so sorry.
Easily done. Easily done.
Okay, thanks for reminding. So back to this repo 03 custom error handling. Right. Earlier on, I can walk you through the deployment for cafe, the coffee, and tea. And the only thing difference here is in the custom resource, the virtual server. Right. In here, there's a /coffee and /t. In the coffee, what I want to do is, if let's say I detected the upstream server is 502, instead of returning 502, I'm going to return 200. And I'm going to return this body. It's to say, hi, oops, this is embarrassing. We'll be back shortly, right? Now, if you notice, I've intentionally to use some simple HTML tagging. So with this kind of give you an idea, and you can do a lot of the customization, different type of branding, different color coding as well, right? So right now, just back to my code. All I need to do is to do the deployment for this one, right? So everything is running. If you want to do a check, while waiting for the pod to deploy, so the pod is up and running. Now, if right now, if I go to the coffee service, right, everything's running fine. Now, what I want to do is I intentionally do the scaling, right, to 0 for the deployment of coffee, right? By doing that, if I do a get pod, you realize my coffee services and my coffee application is down. There's no available versions of running, right? If right now, if I do a refresh, oops, this is embarrassing. We'll be back shortly. So again, I want to kind of show you this. You can easily customize these messages or different branding as well. Right now, if later on the application come back online, I do a scale replica to 1. If I do a refresh, we just need to wait for the pod to be up. So everything back to restore, and then you get applications as well. So so this is kind of first use case, how easily to configure custom resource, custom error message. On the second demo, I want to show you is on the blue-green deployment. Now, in this blue-green deployment, and the 04 blue-green deployment, sorry, let me go back to here. I have one simple deployment. There's a there's a green bullet. In the web page, there's 300 different type of bullets. There's a green bullet as well as blue bullets, right? So depending on the ratio that I can adjust how many being returned to the page, right? So right now, get back to the virtual server custom resource. Again, there's an upstream server, the green bullet as well as blue bullet, right? In this in the initial setup, I say 90% will go to the blue bullet, and 10% will go to the green bullet, right? So this is as simple as that. Right now, all I need to do is I apply 04 deployment, right? So let me just refresh it. Yeah, so as you can see, about 90% of the bullet is in blue color and only 10% is in green color. So let me just, just give me a second. Let me turn on the developer tools. Okay, the reason why I do that is because I want to disable the cache and I want to do the auto refresh. So right now, every second, you will just keep on refreshing. I want to see you. I want to let you see the real-time update. Right now, what I can do is I want to adjust the ratio, right? So I want to easily adjust. For example, to make it more drastic, I put a 50% and 50%. 50%, right? Apply. As you notice, 50% of the bullet will be in green color and 50% of the bullet will be in blue color, right? Now, again, if I very find comfortable, my green versions is up running very fine. I can even go to 90% and etc. Right? So I do a right. So you notice 90% of the bullet will be in green and 10% will be in blue. So it's how easily you can control to do the ratio distributions or even do advanced routing based on header, based on cookie, and etc. Let's conclude this round of sharings. Pass it back to you, Owen.
Thank you, Michael. That's a great demo. I love the blue-green example. It's a very common pattern when organizations are deploying a new version of an application. The blue version is running in production. Users are hitting that version and getting the service they need, but you want to test an updated version called the green version. You can then deploy that updated version onto your OpenShift platform, and using the technique that Michael showed, you can direct maybe 10% or even just 1% of traffic to the new green version. You can monitor and test that running in production, And if it succeeds, it meets your targets of reliability and performance, you can then adjust the parameters exactly as Michael did to then wind up the traffic so more users start using green until eventually you've achieved successful rollout and you can tear down the older blue version. I mentioned before that one of the challenges of using traditional Ingress resources is the dependency on annotations. And the challenges that come with that include the fact that they're not type safe and that they are globally applied. The NGINX Ingress resources don't use annotations. Anytime there is a particular parameter that you might want to configure, including very fine-grained parameters such as timeouts and keep alive parameters and health check parameters, those are all exposed within the spec of the NGINX Ingress resource in a type-safe and locally scoped fashion. So you can very easily attach and fine-grained control anything from the cookie parameters to the health checks, to the timeouts, to the load balancing settings. This means that you have a much safer, more reliable way of configuring the Ingress controller and much less likely to hit scenarios where a user makes a configuration mistake, there's a syntax error, and then changes to the Ingress controller are backed up until that configuration error is fixed. We've looked at some of the advanced ways that you can configure Ingress controller for routing, for implementing error pages and circuit breakers and blue-green deployments. Let's now look at some of the multi-tenant capabilities that you find within NGINX Ingress controller. Simple solutions such as the OpenShift router allow you to configure multiple services from different namespaces. The NGINX solution goes much further than that. Imagine a situation where I have an admin team who are responsible for setting up the front end for applications. They will configure the listen parameters, the SSL parameters, they'll look after the SSL keys, and then they want to delegate individual paths or routes within that application to other teams. We can separate out the load balancing configuration to support this use case. The admin team can configure what we call a virtual server object. The virtual server object listens for traffic, but it can delegate routes here to other resources, virtual server routes, and those other resources can live in other namespaces. So here we're taking the games/API path and we're delegating it to a route called games route inside the games namespace. The team that's responsible for the API for the games then can operate inside that games namespace. They don't have access to the front end listener. The admin who controls the listener can set up their own security policies, their SSL keys, other kinds of policies, and do that in a way that's isolated from the owner of the application. But the owner of the application, the DevOps team who look after the game's namespace, have full control over how traffic is routed within that namespace. So they can listen for traffic and they can define their own upstream, define subroutes. All of the capabilities that we've showed in previous slides are accessible to that user. They can do blue-green deployments within their namespace entirely safely and isolated away from other namespaces and other applications running on the platform. And this rich role-based access control capability based on Kubernetes or OpenShift namespaces is what allows you to achieve large-scale scalability while constraining errors and minimizing the chance that mistakes are going to flow over and impact other users on the platform. Let's now come back and look at the last couple of unique capabilities that you get with the NGINX Ingress controller. I mentioned that there is a concept of a policy. If you want to use NGINX functionality that is particularly advanced and is not constrained just to routing, but addresses other capabilities, then we've captured that functionality within standalone policies. we have a policy, for example, for JOT authentication. On the right-hand side, you publish a resource of type policy that specifies the parameters for JOT authentication. You can then reference that from your virtual server or your virtual server route on a global basis or within a particular path, thus performing JOT inspection and authentication of JOT tokens that are provided in HTTP requests. We can take that further. NGINX Plus also provides support for OpenID Connect so that the Ingress controller can operate as a relaying party within an OpenID Connect flow. And again, there's a policy for that. Specify the parameters that define how traffic should be authenticated and how the relaying party operates OpenID Connect, and then attach that policy to a virtual server route, or indeed to an individual path in order to type safely, authenticate traffic, and require users to participate in the OIDC flow. All of this, as I've said, is safe, it's type safe, it's isolated, and it's also respectful of namespaces. This policy could be deployed in a separate namespace, maybe one that is managed by the authentication team. And then the policy can be referenced from a virtual server or a virtual server route using a fully qualified name that specifies the namespace and then the name of the policy. NGINX Ingress controller supports mutual TLS. You can fine-grained control how the Ingress controller receives traffic. This is the Ingress mutual TLS policy. And then how Ingress controller makes connections to upstream servers. This is the Egress mutual TLS policy. Letting you specify things such as the ciphers that are to be used, the certificates that are to be used to authenticate the Ingress controller, and the certificates used to validate connections coming from remote clients or connections to upstream servers, giving you full support for mutual TLS. And finally, one of the most common use cases for NGINX is to protect upstream applications from large spikes of traffic so they're not overwhelmed in the case of a DDoS attack or another event that increases traffic to those applications. NGINX is very widely used as a rate limiting load balancer to enforce a strict rate limit of the number of requests per second that can be processed based on different criteria. In this case, we have a rate limit policy allowing a rate of 10 requests a second, and it's keyed by the remote address, the remote IP address of the client. So each individual client can send a maximum of 10 requests a second, and if they exceed that limit, they get a 503 error message back from the Ingress controller. Of course, we can capture that 503 error message and replace it with a redirect or a canned response. I'd like to pass back to Michael. Michael, you could show us how easy it is to create a rate limit policy and then do fine-grained control, limiting what that rate limit policy is applied to.
Yep, sure. Right, so back to my screen again. Yeah, so right now I'm going to run through the use case number 6, the rate limiting. Now, in my demonstrations, there's a cafe application which you are very familiar with right now. So right now, what's the difference in this case? First of all, I need to define a policy. Right, so in this policy, it could be JOT token authentication, OICP authentication, as well, and other things as well. But in this case, I have a rate limiting policy. This is just a name. And in this policy, I'm using the 1 request per second. And what's the key, right? So if you're familiar with NGINX, this basically refer to the HTTP header and user-ID. Now, so again, you can refer, you can modify to X folder for IP address, user agent, path, and etc. Right? So right now, one of the common thing is people use rate limiting based on source IP address. But unfortunately, because source IP address might not be very accurate, because if let's say they have upstream load balancer or reverse proxy, for likelihood the upstream, the tier 1 load balancer or reverse proxy could do the SNET, and hence you are not able to granularly rate limit per user, right? So another option you can use is using the header as well, right? So in this case, I created the rate limit policy. How do I tie it together is in my virtual server custom resource. If you notice here, it's /path/coffee. I tie this rate limiting policy for the coffee, but I didn't. If you notice, I do not tie the policy to the tea service, right? So based on this configuration, what I would expect is the rate limiting only kick in for coffee service but not for the tea service. Let's check it out, right? So let's come back to my command prompt, right? So I deploy the things. What happens is I really kind of do a quick command script. So what I'm going to do is I'm going to send I'm going to create a for loop of 10, means for loop of 10. What I need to do is I'm going to do a curl command to this cafe.example.com/coffee, right? Now in this example, I'm going to change the header dynamically based on my my loop integer. So basically you would go 1, 2, 3, 4, 5, 6, 7, and 9, 10. Now, if you remember earlier on, I rate limit based on the header user ID. But in this case, because this is going to be running number, what I'm going to expect is it will not be rate limit, right? So if I run, if you notice, all the requests is 200, just as expected, right? Because it's a different user ID, different header. If I'm going to change this one to the second command. In the second command, assuming I have a very fixed header, it's user ID is 100, like the value is 100. Now, what I'm going to expect is it will do the rate limiting policy will kick in, right? If you notice, the first request go through because I have a 1 request per second of rate limiting. The subsequent request is 503. 503, yeah, like what Owen had mentioned. This one is I can easily customize to change it to other value as well. Right. Then the third test I want to do is now if you notice earlier on I only applied the rate limiting policy on coffee service, but this is a tea service, so I will expect this will not, even though this is a fixed value, it's 100, right? It's the same with the second test, but because this go to the tea service, I would expect this will not be rate limit because the rate limit policy only applicable to the coffee, right? So I'm going to run it. Sorry, yeah, back to. Sorry, I think my screen. Sorry. I mean, just bear with me because of my screen. I think I lost the command. I lost the prompt. No worry. Okay. Let me rerun again. If you notice, this is a T service, but even though the header is a fixed value, but it doesn't go through the rate limiting. Again, this confirm again because my policy is only applicable to the coffee. So right now, just now Owen also mentions this policy could be defined by the SecOps team in another namespace. All I need to do is can just refer to it, right? So basically, this kind of conclude my today demonstrations of some of the simple use cases. But again, if you go to I just want to bring you to attention. So let's say you go to NGINX official repo, not Kubernetes, but NGINX official repo, Kubernetes Ingress. Here, there's a lot of example. You click in, I can show you more advanced use cases, job token validations, and open tracing, etc. And also some of the custom resource use case as well. Right. Basically, this kind of conclude my sharing today and pass back to Owen.
Thank you very much, Michael. That's a great demo. It's lovely to see the different capabilities and how easy it is to access those capabilities using the Ingress resources that we've developed for the NGINX Ingress controller. Sometimes, though, you get to the point where you want to use a capability inside NGINX Ingress controller that is it has not yet been exposed through an NGINX Ingress resource. We've seen OpenID Connect, we've seen JOT, we've seen rate limits, we've seen ingress and egress, mutual TLS, but there might be something else, some fine-grained tuning that you need to do that we have not yet brought into the capabilities of NGINX Ingress resources. And in those particular edge cases, they're rare, but they happen. We have a solution for that as well. You don't need to modify the Ingress controller. You don't need to edit templates. You don't need to hack away with annotations or config maps. Instead, we make it very easy for you to embed additional NGINX configuration into the generated engine through the Ingress resource into the generated config. We call this capability snippets. Snippets allow you to put a small amount of NGINX configuration verbatim directly into the Ingress resource. So here, for example, we have an example that uses an HTTP snippet and a server snippet to implement a couple of NGINX capabilities. We have an HTTP snippet that sets up some NGINX config for limiting requests and for configuring a cache. We have a server snippet and a location snippet that then add additional NGINX configuration. These can be put into the Ingress resource that your users publish. By default, this capability is disabled because it is powerful and dangerous. A user could embed some configuration directly that has a bad effect on the NGINX config. So it's disabled by default, but with a command line option, you can then enable this functionality. And when you do that, that will embed NGINX configuration verbatim directly into the generated Ingress controller config, allowing you to do things such as different rate limit configurations. Here, we're implementing a rate limit with a burst. This now is supported by the rate limit policy that you saw, but shown here to illustrate the concept. Or in the green example, we're implementing a web cache. So we're caching responses from the upstream server into a local cache and ensuring that any responses with a 200 status code are cached for 10 minutes. So you can access any of the NGINX configuration through the NGINX Ingress controller. It's a uniquely powerful solution. So we've brought together a number of different capabilities through the NGINX Ingress resources. We've given you the ability to do very fine-grained routing for traffic so that you can support things such as blue-green deployments or private deployments. We've given you the ability to do multi-tenant configuration securely and safely. The ability to access additional NGINX configuration through policies, and the ability, where necessary, to directly manipulate the NGINX configuration. But my question for you is that is this functionality that you could foresee using within the Ingress controller? Maybe this is something that is just too complex. You wouldn't want to touch it. Maybe it's something that you might want to put somewhere else at the edge load balancer. Maybe it's something that you'd put the burden on your developers to implement this functionality in the app. Or maybe you feel this is functionality that you could use in production, capabilities that are unique to NGINX, but would allow your production platform to be more agile, sophisticated. And as we look at the results, let's end the poll here and share the results. So we're seeing overwhelmingly, over 80% of our respondents are saying, yes, this is a well-formed, well-designed set of functionality, and the Ingress controller is the right place to put it. These advanced capabilities are unique to the NGINX solution. So that's something I would encourage you to take a look at as you're planning for production-ready, production-scale applications on your OpenShift or Kubernetes platforms. There are other capabilities as well, in addition to this, that you can leverage with the NGINX Ingress controller. So we're not just limited to how we route traffic. With the NGINX Plus solution, you also have the ability to embed a full web application firewall in your Ingress controller. When you think about how your OpenShift deployment is orchestrated, you have a number of options as to where you deploy different types of technology. And one of the pieces of technology you'll almost certainly want to deploy will be a web application firewall. This is a proxy-based solution that inspects traffic as it comes into the application, and it matches that traffic against a set of signatures, a little bit like a virus scanner. And if the traffic fails to match the signatures, or if it matches signatures that relate to known bad requests, then the web application firewall will drop or prevent that traffic proceeding to the application itself. Web application firewalls can process a large number of signatures and protect applications from a large number of known vulnerabilities, whether it's attempts to exploit something in the PHP platform, a file traversal, or maybe to exploit an Apache struts vulnerability. These are things that web application firewalls are designed to do. At the start of this session, I mentioned that you have decisions as to where different pieces of technology are deployed and who owns those technologies. And a WAF is a great example of one that requires some careful thought. The WAF might be managed by your NetOps team, a centralized operations team who deploy a single consistent WAF policy at the edge in front of your OpenShift cluster. But what is more common is that the WAF is managed by a DevSecOps team, a team that's very close to the application, who manages WAF configuration that is specific for each individual application. With the solutions from F5 and NGINX, you can make this choice and deploy our App Protect WAF at the place that's right for you. You can deploy it at the edge on top of NGINX Plus or Big IP, on the Ingress controller, or you can deploy it directly inside the OpenShift environment, protecting an individual service or even individual pods. The edge is an ideal solution when you have a SecOps team providing global scope, so a consistent WAF policy across all applications. But the Ingress controller is also a great place to deploy the WAF. The reason for that is that the Ingress controller is configured using the Kubernetes API, and we expose the WAF config through the Kubernetes API. By putting the WAF directly on top of Ingress controller, you have a simpler, consolidated environment that is more efficient and lower cost, but you can still fine-tune the WAF policies per URI or per service. In the next Ingress controller release, coming in a month's time, you'll have the ability to use policies directly to attach in a fine-grained fashion a WAF rule to a particular route. I'm curious to know, is a web application firewall one of the pieces of technology that you use in production to support your applications? And what is your DevOps team attitude to a WAF? Do you need to use a WAF at all? Is it handled somewhere else by a NetOps or a SecOps team? Do you want to deploy it in the Kubernetes or OpenShift cluster, but not manage it? Or do you want to give full control to your DevOps team with the ability to manage it? And if we look at the poll, overwhelmingly, with almost 50% of the responses, people are saying that ideally they would want to be able to deploy the WAF in Kubernetes or OpenShift, and they'd like to allow the DevOps team to have the ability to manage that WAF and control the rules. The good news is that you can do exactly that with the NGINX Ingress controller. The commercial solution that uses NGINX Plus has an optional module that will also embed the App Protect WAF into the Ingress controller. And the configuration for the WAF is fully controlled through the Kubernetes API. The signature database is built into the pod when the pod is mastered and deployed. And then the policies that refer to signatures are provided through the Kubernetes API as Ingress resources and other types of resources. This gives you a very, very high performance solution that's entirely native to Kubernetes or OpenShift. And most importantly, all of the configuration is done using the OpenShift or Kubernetes API. So it's familiar, it's consistent, it can be easily automated. The final thing I'd like to cover as we wrap up this workshop is the question of how does one get traffic to the Ingress controller in the first place? The Ingress controller runs as a series of pods exposed as node ports on the cluster, on your Kubernetes cluster, and typically you have some sort of edge load balancer that sits in front and sprays traffic across the nodes. There are some optimizations that can be made to improve the efficiency of that edge load balancer configuration, to improve the performance, and to reduce the amount of traffic that is bounced across the OpenShift internal network, using node selectors and constraining traffic to the local node. There's optimizations that can be done, but there are also streamlined solutions using either cloud load balancers with type equals load balancer, using NGINX or Big IP or some other sort of edge load balancer. So quickly, again, curious to know what sort of solutions are people using. And as results are coming in, it's fairly consistent. We have about half of the users who've responded are using F5 Big IP as the external load balancer in front of their OpenShift cluster. Then maybe 20–25% are using a cloud load balancer. So they're using an OpenShift cluster running in AWS, in Azure, or Google. A few using NGINX, some using something else. A couple with a direct connection, so no front-end load balancing. I'd like to give you a preview of a solution that we're building at F5 to make this process more streamlined. We have a solution in development called F5 Ingress Link. The purpose of Ingress Link is to give a very, very simple but powerful connection between the Ingress controller and an external Big IP device. So with a single configuration file, the CRD on the left-hand side, it'll be possible to say, I wish for an NGINX Ingress controller to be exposed on a particular IP address. The Ingress controller is identified using a selector. And then the Ingress Link technology will take over from there and automatically configure the front-end Big IP device to load balance traffic to the Ingress controllers. As the Ingress controllers scale up and down, the Ingress Link solution will maintain the configuration on the Big IP device to match. So this Ingress Link solution, under development and due for public release in a couple of months' time, will make the task of getting traffic into your Kubernetes cluster or OpenShift cluster so much easier. It is ideal if you are operators or owners of a Big IP device and want to extend that device through and provide services to your DevOps teams, giving you more flexibility, faster deployment, and close alignment with both the needs of operations and development. So as we wrap, what have we learned? We've seen that OpenShift and Kubernetes both come with default Ingress solutions, either the OpenShift router or the Kubernetes community Ingress controller built on NGINX. And those default solutions can be limited for large-scale production use. On the other hand, if you use a solution such as NGINX's Ingress controller, either with NGINX open source or NGINX Plus, you get a much more capable solution to meet the needs of your DevOps teams who are deploying applications on OpenShift or Kubernetes. You get greater scale and greater performance. Greater scale with multi-tenancy to support multiple teams in a safe and secure way. Greater performance with the performance optimizations in NGINX and NGINX Plus, the ability to have very fine-grained control over configuration to tune the performance, and with NGINX Plus, the non-stop reloads using the NGINX Plus API. You get a broader set of features. Michael demonstrated the routing, the rate limiting capabilities, the way to do blue-green deployments, the way to apply error messages to create circuit breakers, a much richer set of functionalities exposed to your users. You have a solution that's more secure. It's developed and managed from a single source. At F5, we are both the developers of the underlying NGINX load balancer proxy and developers of the Ingress controller that sits on top. We can provide excellent, the best quality support for that solution, and we partner with Red Hat to give you an integrated support experience. Together, NGINX, F5 and Red Hat have very deep experience in architecting, planning, deploying, and helping you operate large-scale OpenShift and Kubernetes environments, helping you take the monolithic applications you have running on bare metal on Red Hat Enterprise Linux, decomposing those into microservices, deploying them inside OpenShift, and delivering those at scale in a production-ready fashion. We're here for one-on-one help, for one-on-one guidance, should you need it. Please don't hesitate to reach out with any questions. We will send out to all attendees the details of this webinar, the slides, and a link to the GitHub resources that Michael used. So I'd like to wrap and share and say thank you very much for your time and attention today. It's been a pleasure sharing with you what we're able to do at NGINX and F5 to help organizations scale. And I look forward to talking with many of you one-on-one over the next few days to help you understand what we can do to help you scale and production ready the applications that you're running. So thank you.